Okay, so we are going to spend today looking at algebraic fractions because we have to extend what we already know about them. So if you remember, we get questions a bit like this when we face them. There was one of the ones in your end of year assessment which a lot of people got wrong. So I'm going to quickly recap it today. If you are absolutely fine with this, then just kind of skip through the video and think, yeah, I can do all that, then carry on and just work on the exercises. However, if not, I'm going to go through it now. So the first thing I want to highlight is when we get things like this, one of the really common mistakes I see is people go, oh, there's a -3 and a minus on the top and there's a -3 on the bottom, so I can just cancel those all out. You cannot do that. All right, if I can just imagine just for a second, if I have say I have 1/3, there we are, and I've got this, say I've got that. All right, so now I know that is well, that's 3/5, right? But if I was going to try and do that, then I would go, oh, there we go, cross that out, and I'm just left with a third, and that is obviously not the same as that. So you cannot do this. Please do not do this. Same as if it's a letter. I can't go, all right, okay, there's an X here, and there's an X here, so I'm just going to get rid of one of those. I'll cancel one of those out. So I'll get rid of that, and I'll just have X left. Please do not do that. Don't forget, the best way to check these is to use some sort of substitution. So once you have simplified something, get a value, just put, like, for example, say X is 3, substitute that into that, get an answer, substitute it into your simplification, and make sure it gives you the same value. Right, so just a reminder about how this method works for actually doing these, not all this mess that I put on here. So simplifying fractions normally, that is, I know we can all do that, but why can we do it? So we say, oh yeah, halve it, divide it top and bottom by 3, that kind of thing. Well, the reason why we can do this is I can, for example, write the top as 2 times 18, and I can write the bottom as 2 times 27. And then if you remember how fractions, multiplying fractions work, so like 1/4 times 3/5, multiply the top and multiply the bottom. Okay, I can use that idea up here to kind of in reverse, so I could have gone from this to this. I'm going to do that here, so I'm going to change that to 2/2 times 18/27. And what's 2/2? Well, that's 1. 2 divided by 2 is 1, and 1 times something. So this is basically that's just 1. So I'm just left with the 18/27. So that's why I can divide the top and bottom by the same number, because I'm just using that concept. I'm going to divide the top and bottom now by 9, and that's my simplest form. Similarly with this one, I could break that into 45/60 times A/A times B/B times, well, that would be 1/C, because that C has still got to stay underneath. So at the top, hopefully we can see I've still got 45A, 45AB. The bottom, I've got 60ABC still. All right, but that obviously cancels out because something divided by itself is 1, something divided by itself is 1. 1/C, that doesn't cancel. 45/60 would cancel to 3/4. So that'd be 3/4C. So a lot of the time with these, we are just cancelling out, going A and A, B and B. 45/60 is 3/4, and you would do it that way. That's absolutely fine. I'm not asking you to change your method at all. I'm just showing you about why that works, so that hopefully we can apply that reasoning in future. Similarly down here, 12/32, divide the top and bottom by 4, that's 3/8. Now please bear in mind that this is E times F squared. It is not EF squared, because that would be E squared F squared, and I think that's a mistake that some people made in the exam. All right, this is different. This is E times F squared. Right, so these E's cancel, they disappear. F squared divided by f to the 5, if you think about it this way. So it's important to think about our flexibility with these questions. Well, what do I do to the powers? I subtract. So 2 take 5 is minus 3. It doesn't really help us here. But I'll cancel the f squared there. If I take an f squared out to the bottom, I'm left with f to the 3. So I'm left with, in total, 3 on the top. That's the only thing left on the top. And on the bottom, 8f cubed. Okay, so applying this technique to more algebraic ideas. Here, again, if we just think, I could rewrite that if I really wanted to as x over 1, oh sorry, x plus 1 over x plus 4 times, well, there's an x plus 2 on the top and there's an x plus 2 on the bottom. And same here, x plus 3 and an x plus 3 at the bottom. Well, again, those second sets of fractions, something divided by itself, well, that's just 1. That's just 1 as well. So these kind of just disappear. So I'm just left with x plus 1 over x plus 4. Right. Again, if that was my answer in exam, I would like to say, all right, I'm going to just say that x is 5. I'm going to substitute that into there, get an answer, and then that should, in theory, give us, if I put it the same to that one, so I've got 6 over 9, which is 2/3. Alright, so if I put x into 5 into this, I should get 2/3 as well. And it's a really useful check to know that I've got the correct answer. Right, okay, so going on to the more complex ones. So there are 2 steps for solving these. Step 1, factorise as much as possible. Step 2, cancel common factors. Alright, so for this top one, don't forget the first step with any factorisation, can I take any factors out? Yes, I've got x in both these terms and I've got a y in both these terms. So I can take xy out. To get that, keep that first term the same, I need x because that would multiply out to give me x squared y. That's great. Plus 1 because I need that x y times 1 would give me that one there. Alright, that's all I can do in terms of that factorising. Down the bottom, the only thing that's common is y. And then I've got an x would give me the xy, and plus 1 would give me the plus y. So just checking the top. At the top will give me x squared y, great, plus xy, brilliant. The bottom, xy, great, plus y. Again, the worst thing I could see you do in one of these questions is to go, that cancels with that. That is not true. Right, but now I've got this going on up here, I can cancel out because it's this times this times this, and underneath it's this times this. So I can cancel out the y's, and I can cancel out these x plus 1s. And I'm actually just left with x. So step 1, factorise it as much as possible, and then if you do not get common factors, double check your working because they're very unlikely to give you a question which says simplify and you not to have like at least a couple of common factors. So you should always have common factors to simplify the end. So for some questions like this, look at the top. There are no common factors at the top, but it is it's a quadratic that I can solve, that I can factorise, sorry. So that's just a basic factorising. So I'm looking for 2 numbers that multiply to give me -2 and that add to give me 1, like 2 and -1. So those are my 2 brackets at the top, x plus 2 and x minus 1. Right, how about underneath? Now, this is a really common thing that they put into these simplification questions because people struggle to factorise something like this. And you do have options. So you could use this same technique. So we could go, right, I need two numbers. Remember, it's always the two numbers that multiply to give me the number that's on its own, the constant, and the add to give me the coefficient of x, the number in front of x. Well, here I've got no x. I've got x squared, that doesn't count. I've got no x, so that would be 0. And without too much hassle, you can work out that it's -2 and +2. So that would be our two brackets. If I'd have got something wildly different, I would have checked if it didn't simplify. But here straight away I can see that that cancels with that. So you're just left with x minus 1 over x minus 2. This thing down the bottom, it came up in revision. Remember, that is called, I've got something squared minus something squared. And that is called the difference. So difference minus, those are synonyms, difference of two squares. And it always factorizes into something quite simple like this. So for example, I know straight away that x squared minus 100, straight away without much thinking, it's x plus 10 and x minus 10. Even something a bit more complex, like 9a squared minus 64. Well, it's the square root of the first term plus the square root of the second term, and the square root of the first term minus the square root of the second term. Those are just an aside to remind you about the difference of two squares. If you can't get that, please make sure you do practice on it, because it always comes up, and it really often comes up in these simplification questions. Right, another example, slightly more complex, because you see the top shouldn't be too much of an issue. However, the bottom is one of those tougher factorizing things that we have got. So I'm going to do the top. The top factorizes to x plus 3 and x minus 1. Right, how about this base? Right, so remember this technique. So this is when we've got a number in front of x squared. Right, so I'm going to look for two numbers that multiply to give me, right, and I multiply these, 2 times minus 3. Give me, you've got multiply to give me minus 6, and add to give me this number here, so I'm going to add to give me 1. And then I put this 2x here and here. That's me set up. Right, so I need two numbers that multiply to give me -6, add to give me 1. I can work out that that is 3 and minus 2, and these go underneath here, 3 and minus 2. If this simplifies, then I simplify it. That doesn't. However, that one does. Divide the top and bottom by 2. And those are our two brackets. So 2x plus 3 and x minus 1. And lo and behold, same factor, top and bottom, and they cancel. So you're left with x plus 3 over 2x plus 3. And what are we not going to do? What are we not going to do? We are not going to cancel out those 3's. That is our final answer. All right, so it's a lot of recapping there. It's a lot of revision this lesson. It's an important one to get, especially because we are going to extend in the next couple of lessons when we're dealing with other sort of algebraic fractions. So let's just use today to practice these and get our algebra skills a little bit of a polish.